Hello, my name is Jiwon Lee and I'm majoring mechanical engineering. First things first, I'm really thank you for giving me this kind of opportunity, and today I'm going to talk about the thing I did last semester for capstone design project. The title is The Autonomous Car. The content would be like this. I'll divide it for three parts. I'm sorry about the issues with presentation and okay. I'll divide it for three parts: introduction, project, and conclusion. Also, each part have some chapters like this, has some chapters. And first part is about the topic I did. The topic of my project was making an autonomous car by using object recognition of AI. To make the final goal, I used these three things: RC car from Justin Nano, and made steering part by using Navita L4T, and the recognition part was made of this camera. Um, this part can give you the information about why we choose to make a self-driving car, how did it process the tests, and what results did it take. A self-driving car can drive itself without any drivers, and it has been highlighted for the next generation industry. So by considering this trend and situation, we put this on the table. First, the technology of autonomous. Second, the present development level of it. Third, some issues. And that helped me be a capable person of making an idea about diverse use of self-driving technology and solutions for the issues. We did our project by following this process, collect the data, make the car study, put a control algorithm into the car, and do the tests. We made the car if there's objects, avoid them, or just go with the tracks with many cars. From now on, I'll tell you about some basic information about our team and project. There were 7 people in our team. The meeting of our team usually held twice a week, and we did coding, revised some errors, and checked the hardware. I attended almost every meeting and took on coding part with other members. We made the goal with RC car from Justin Nano by repurchasing or modifying some parts like camera, board, and wheels. I could learn kind of basic concept with Raspberry Pi in last year, and this year, I did the tests to achieve the final goal with Justin Nano. From now on, I'll show you about the Raspberry Pi. I learned and practiced basic driving skills such as control to go forward, backward, left, and right by using the book, and I did with keyboard or cell phone. This is the performance video we did. You guys can see we controlled the car with our cell phone. Okay. Before I'll tell you about the project we did with Justin Nano, I'll tell you several technologies that can be put into self-driving car: computer vision, deep learning, and AI, and controlling system and other things. And OpenCV is usually used for computer vision skills, which we used in this project. From now on, I'll let you know about the process of our project with Justin Nano with coding with it. Jupyter Lab was used for the coding of Jetson Nano Developer Kit, and it has some advanced skills that can fulfill the lack of Jupyter Notebook, and I disregard the basic steps, very basic steps in this presentation for the time limit. So let's move on to the code. This is one that can define the road following action and the data it will collect. And This is the script for collecting data in order to train our mechanical training model by capturing images with the camera. So you can see the words set data and update count, save snapshot. Okay, in Jupyter clickable image widget library, we can preview the camera feed by generating a clickable image widget. In these images, some range with that green mark should be picked and it is saved and updated. This was quite an important part to make the car go accurately following the lines. We could bring the CNN model trained in advance and solve the new categorization problems by revising a fully connected layer of its model. And this is about it. This one is the code that used the trained model and implement the live image recognition system. The system captured the images from camera and put it into the model. This made the system get the predicted values and process the next prediction. Finally, there would be a video with the circle around the object. And this one is the next part of previous code. In this part, I put the car in the track and ran the program. With this code, the images were saved when I picked the spot in lines after the car moved in screen. The first one, these are the pictures and you can see it. These are the pictures and you can see it saving in road following files. Also, in here, we changed the value of epochs, which means the count of training the model. After this process was end, we could check the car driving itself by recognizing the tracks. And when we made the epochs value over 10, our car went wrong, so we adjusted it under 10 times. From now on, you can see the process of recognition object. We set the basic self-driving code for recognizing objects, found the jet racer / notebook, and opened the file, this one. Ran the cell and devoted the optimized model with this code. And okay, doing this code, we could make the images process output. Also ran the value of the maximum speed of car with car throttle in here. If the value was too high, the car could get out of the trace. So we set the value under 0.7, and I remember the highest level of speed over our car was 0.68 or 67. With the previous coding process, we performed our goals, following the lines and avoiding the objects. Making more perfect, we retried the collecting data process or redefined the way to collect the data. When the car recognized correctly and ran to the right spot, it could avoid the obstacles. Thank you. And it's time to do the question and answer part. Oh, before it, I'll show you about the performance video we did. Oh. Yes. Yes. You can see our car avoid the obstacles and follow the lines correctly. Yeah, it's real time to do the question and answer part. If you have any questions, please let me know. And thank you for listening my long presentation. Thank you.